Okay, so let's have a look at 5/6 to the power of -2. What's this going to be equal to? Okay, good. So break it down. Tell me how you got that. How'd you get that then?
Like 36 divided by 25.
Good, exactly. So first of all, you flipped it upside down. You saw this negative, and you thought, I know what a negative power means. It means flip it upside down. So I get 6/5, and of course I've got to change that to a positive. Okay, okay, good. And then just square the top, square the bottom. 6 squared is 36. 25. Good. Happy with that? All good? Excellent. What about 8/27? So the -2/3. Good. Talk me through how you get there, though. Here's how I would do it. I would deal with that negative first. That's what's bugging me. Right? This -2/3 is what's bugging me. So if I raise something to any negative power, what does that mean? Flip, right? So let's get that done first. Then I don't have to worry about negatives ever again in this question. All right? Okay.
27, 3, 2.
Exactly. So the idea here is that I can take the denominator. So if I have a denominator of 3, what does that mean?
Then only 3, 9.
It becomes a cube root, right?
Yeah.
So cube root of 27/8. And I have a squared there still. Okay, you notice I'm not putting brackets in here now because I don't care what order you do it in. Okay, but if I take the cube root of a fraction, works in the same way as every other power, cube root at the top, cube root at the bottom. So what's the cube root of 27? It is 3. What's the cube root of 8? It is 2. And I just need to make sure I square everything in there. So what do I get? Square the top, square the bottom, there's my 9/4. Okay? We all good?
Yeah.
Smiles all round, Fatima, you okay? Yeah, good. Alright, okay, more of the same here. Are there any questions, of those of you which have gone through this? Oh, that might be an interesting one to do. Are there any questions which you particularly want to go through? No? We all good? So for those of you which haven't looked at this, please make sure you do have a look at them. There's just a few which I want to pull out. So have a go at this one. Okay. Okay, could you have a look at this one for me?
Yeah.
So we have 2 to the power of x plus 6 is the same as 2 to the power of 5. How could I work with that?
You just cancel throughout. Because they're same, basically the same as the 2. So it's just x plus 6 equals 5.
Absolutely right. In case you didn't catch that, we've got 2 to the power of something is 2 to the power of something. So therefore those powers have to be the same. That's the only way they can work. Is that clear? Yep, okay. So we get x plus 6 equals 5. What's x equal to? -1. You happy with that? Yeah. Okay, so then can I extend it to this? What about this one?
You move it over. You move it over, so it's 8 equals 16 times 2 to the power of x plus 1.
Excellent. So that is one way you could do it. Megan, you had another way, which I really like the sound of. You were noticing that 8, 16 and 2 have something in common. Like they can all be written as 2 to the power of something. Yeah? So Agnes, you were going to multiply 3 by there. That's totally fine. You will get the right answer. But let's have a go at Megan's way, which is saying, let's change everything in 2 to the power of something. Okay? So, 8. What's that? That's 2 to the power. That's 2 to the power of 3. Good. That's already 2 to the power of something. Because we don't know what that power is. 16, that's 2 to the power of 4. Good. Okay, now I can just employ my laws of indices. So, if I'm dividing 2 things with the same base, what should I do in the powers?
Minus.
So it becomes 2 to the power of 3 minus x plus 1. I've made a mistake, haven't I? What's the mistake?
The 1, you mean minus 1, because it goes inside.
Good, exactly. So what I need to do here, the way which I've written it, in my head I'm thinking, oh, I just take that and I minus that. But of course I want to minus all of that. Okay, so make sure you don't miss out that bracket, otherwise you get something very different. Okay. In fact, what would this now become? So what's 3 minus x plus 1? 2 to the power of 3 minus x, and then I also have to take away positive 1. So that becomes take away 1. We okay with that? So I'm taking away all of this bracket, so I've got to distribute this negative 1 over everything inside the brackets. So I've got to take away an x and also take away a 1. Hence why I have to put take away 1 there. Is that okay? That's a really important point. It's a common mistake which people make. So don't fall into the trap. Okay, what's 3 take away 1? 2. So I have 2 minus x to the power here. 2 to the power 4 over on the right hand side. So I just basically do the same thing as this, right? So that's the same as that. So 2 minus x has got to be equal to 4. If I solve this, what do I get? Negative 2, right? You happy with that?